The audio begins with a precise mechanical whirring and faint click.
The robotic vision system captures 360-degree images, verifying surface texture against the CAD model.
The data confirms the precise squareness and flatness. It's a perfect match. Verified.
Proceed with the initial machining sequence.
The titanium offcuts undergo Process B, ensuring pristine conditioning. Powerful streams of inert nitrogen rapidly evaporate all moisture.
Every surface is scrutinized. This digital checklist ensures we maintain the zero-tolerance policy essential for aerospace manufacturing. A specialized 7-axis robotic cell meticulously shapes the titanium, ensuring the precise aerodynamic. The titanium turbine blades undergo final non-destructive testing. An automated probe detects anomalies. The certified titanium turbine blades and matching fasteners are assembled into specialized, sterile component kits. Each turbine blade is meticulously inspected, ensuring aerodynamic perfection before installation into the engine core.
Through Process B manufacturing, each titanium blade slides precisely into the rotor disc, building the core compressor stage.
Engine pushed to full military thrust.
Set it down slowly, ensure alignment with the mounts.
Confirmed. Moving to secure the fasteners.
Torque set to specification.
Reading confirmed.
Secure.
Clear on the left side. Copy that. Moving to the starboard engine check now.
Canopy closed, locked, harness secure, flight controls checked, engine start sequence initiated.
The structural integrity of its internal components, especially the titanium derived from Process B, allows the Mirage 2000 to achieve such agility.
Mirage 20, telemetry confirms stable engine performance. Titanium backbone nominal. Mission successful.
Okay, cross-referencing engine temps now.
Turbine blades look good, no stress fractures visible on the backbone.
The highly polished titanium blades show no impact damage. This confirms the flawless performance of the Process B components.
The detail confirms the secondary product maintained its structural and aerodynamic integrity throughout the flight envelope. The component is performing exactly as designed.
The scan on the titanium backbone is complete.
Thermal readings are nominal, well within operational parameters.
Precision engineering on these blades is exactly why we can push the envelope.
Absolutely, it's the backbone of the Mirage's reliability.
Nothing else comes close.
The Mirage 2000 requires precision maintenance. Thanks to the robust titanium components, this crew achieves.
With afterburners blazing, the titanium backbone drives the Mirage 2000. It is this raw material, transformed. As the simulation demonstrates, the smooth, laminar airflow confirms the functional superiority of the finished product.
Successfully deployed, the Mirage 2000 relies on its titanium turbine blades, a testament to precision engineering and endurance. Ensuring global reach requires unparalleled operational excellence, built on precision-engineered secondary titanium components.